Hi everyone, we're moving on to proving triangles congruent. This is Mrs. Osher.
And Ms. Perrier.
And let's get started. So, first things we need to know are criteria that allow us to say triangles are congruent. So you might be thinking, well, if it has all equal sides and all equal angles, they must be the same shape. Yes, but there are shortcuts where you can do it with not having to do all three sides and all three angles. So if two triangles have two angles the same, two sides the same, and two other angles the same, it's called the ASA criteria. Now notice that the S is in the middle of the two A's. That's because as you look at it, this is how that criteria would look in an image. You have an angle with a side in between the other angle. We have one arc on the left and then two arcs on the right, showing that those are the equal angles to one another. There's a lot of pictorial information here. This can also look a few different ways. Let's say that was the side and the angle is on the bottom right. In order for angle side angle to work, angle would need to be that top angle. And then if that left side was it would have to be the top angle on the bottom left, because again, angle side angle, that criteria means that you have two congruent sides in between two separately congruent angles.
Next one, we got angle side, so that means we need two angles congruent and also a side. So again, we already have these notes filled out for you, but to look at it and have the pictorial picture, please write these triangles and what each of them mean off to the side here. And again, we'll have an angle congruent to another angle, and then finally our one side.
And the side is always outside of those two angles. So for angle side angle, it was two angles and a side. The side was in between. This time it's not. So it could be those two with the two angles there. Side angle side is your next criteria. Again, these are written in order for a reason. Side angle side means two sides with an angle in between, so it would look like the pictures that you are seeing now, where you have two sides and then the angle that's touching with those two sides is the congruent angle. Here we have side angle, so then the bottom would have to be that other side to make side angle side work. And then side side side.
Side is just where all three sides are congruent. That one is pretty straightforward, as you can see on the picture on the screen.
Then there's one special one, and I say it's special because it has only two letters where the rest have three, and it's HL. Now HL stands for hypotenuse leg. So I like to say it still has three things, because in order for a hypotenuse to exist, you must have right triangles. And from there, it's saying that in a right triangle, you have a pair of hypotenuses that are congruent and a pair of legs that are congruent. And when you have that, those two triangles must be congruent. And then again, because it's hypotenuse leg, it could be the other leg as well. So which ones don't establish congruence?
So the first one we have is angle, angle, angle. For these, you have all the angles would have to be 60 degrees, and this one would not work because no matter if the triangle is smaller or bigger, each of those angles could be 60 degrees. Therefore, they cannot be the same. So congruent means the same. We'll learn later that there is another term that we're going to call this. But angle, angle, angle here does not work for them to be congruent. And again, congruent means the same.
Another one that doesn't work is side side angle. And yes, I'm fully aware of what that spells backwards. Hopefully that's a way that you'll remember that this does not work. Now here's what it would look like to kind of show you why it doesn't work. So I have two sides and an angle. That's what I'm trying to show you there with my red things. Now I put the two sides together and the angle out there. The angle's dotted because it doesn't have a specific length. So I could connect it there with the blue and I made a triangle. However, I could also move that other red side down and meet there, and if you'll notice, that also creates a triangle. So I'm making two different triangles out of the same three pieces, two sides and an angle, and because of that, this does not say that they are congruent because I could make two different triangles. All right, now we're going to go through and actually test some of this criteria. Okay. When you are looking at these, you want to start paying attention to a few different things from the pictures. Okay. One of those things is vertical angle. So at vertex C, you have two angles, one on the left, one on the right, angle DCE and angle MCN. Those are vertical angles. Those are congruent as a reminder. That's helpful sometimes. Okay, so these are congruent, and if I go through the list of 5 on the top of your page, I see I have two angles, O and X, that match in both, and then they both have a side, DC and CN, that are labeled congruent. So this would be the angle side criteria, because that side marked with 3 marks is not in between the X and the O, it's outside of it. That's why it's AAS, not ASA. And then we would write, this is called a corresponding statement. So DEC would have to go in the same order as NMC. The first triangle, you can pick the order, and then you have to pick the corresponding parts for the second triangle.
So for this one, we got our two angles here that are labeled, and we have this thing called a reflexive property. So as you can see, these two triangles share a side, and that is going to just be called the reflexive property. So that means they share the side, so that means that it will be congruent to one another. So yes, these two triangles are congruent by angle, side, angle, and as you can see, the side is in the middle between the two angles. Therefore, when we write our statement, we have triangle DEC is congruent to triangle REC, and again, we're just going by corresponding parts.
Okay, moving on to letter C. Again, I see I have the two angles that are marked with like O's. I have two sides that are marked with the double hashes. So I need a third thing in order to make one of these work, because it's not HL because I don't have a right angle. So that's where I look to the picture again, and I see that I have the reflexive property. CE is shared by both triangles. Because of that, this would be side, angle, side. And then again, I would mark my triangles in the corresponding order. Okay, letter D. This is actually a no, and the reason being you have 17 and 17, so there's a side. You have 4 and 4, there's another side. And then you have the two circles, which is an angle. Because that angle is outside of the two sides, what I mean by that, it's only touching one of the sides. This is side, side, angle, and that's a criteria that does not make triangles congruent.
And again, for E, this would also be no, because as you can see, we have three angles labeled here, and that would consider angle, 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 so that one does not work.
All right, so that's just getting the criteria. Where we're going with this is we're actually going to write proofs, and they are always in the form of statements and reasons. Now, it's very simple to start a proof. You always start with a given. You also want to make sure you're labeling your picture as you go. So as a strategy, I would first start by labeling angle BDT congruent to angle GTD. And I do that by making arcs. So just as you see in the picture there. Then I would mark side BD congruent to side GT. And I'm always aiming to go for one of those congruence criteria. My goal is to prove these triangles congruent. So I'm looking for it. Is this side, side, side? Is this side, angle, side? All of those. So right now I'm out of givens. That will always mean you look for the reflexive property or vertical angles. In this case, I have a shared side, side TD. So that is going to be that missing piece that I need in this proof. And the proof is you basically just writing instructions to the reader of how you're going to say that these two triangles are congruent. And it looks like this, which is already there for you. So the first two are given. In order to start, if you think about start playing any game, you have to have some rules, right? Some instructions to follow, ways to begin. So those are the given. They're saying, okay, we're starting by telling you this piece. The piece we added to it was the reflexive property. So that goes in next because that was the next piece of the puzzle. Then, because I have three pieces of the criteria met, I can give that final statement that the two triangles are congruent, and the reason is that criteria. In this case, it's side, angle, side, because the angle's in between those two sides.
We got our second one here, so the first thing what I would do is I read the given and label our picture. So we're going to label angle B is congruent to angle D, and we're also going to label the segment AC is congruent to a segment EC. So we got that all labeled. You can write that down in your statement and reasons. So the next thing what I would look for is our vertical angles here. As you can see that we got two right there. So when we write this all down, we have our givens first. Then our next one would be angle BCA is congruent to angle DCE, and that is by our vertical angles are congruent.
Now, if you are lazy, and I don't want to say lazy, if you want a shortcut like all mathematicians do, you do have an option there. Instead of labeling, you can't say angle C because there's too many things at angle C, but if you put a 1 and a 2 into that picture, if you actually write that in your picture, you can then call them angle 1 and angle 2 in your proof if you kind of want a little shortcut.
So we got our three things that we need. So we can say the two triangles are congruent by angle, angle, side. And again, our side's on the outside, so that's what our criteria would be.
All right, next proof. This one's, in my opinion, one of the more basic ones because I have a side given to me. AB is congruent to AD, BC is congruent to CD, and as you see, I put both of those in one statement. Yeah, you can do that. If you just want to write all your givens at once, you can. That's an option, just like I've done here. Then I look for, because I'm out of givens, I look for reflexive property or vertical angles. I see that I have a shared side, so I'm going to put the reflexive property into my proof. And then my criteria for the triangles being congruent would be side, side, side. I have 3 sides congruent in both triangles, meaning that the triangles are congruent.
Okay, so last one, we have our 2 givens. Angle B is congruent to angle D, so we'll automatically label those. Then we have C is the midpoint of AE. So when you think of that, you need to know midpoint cuts things in half, so that AC will be congruent to CE. So we can actually use that in our proof now.
That's the introduction to LT5. That's going a little bit further, just so you guys know.
So when we start writing this, we'll have our 2 givens, and then we got to figure out our third thing. So as you can see, we have vertical angles again. So if you want to write them, angle ACB is congruent to angle DCE, that's totally fine, but you can also write them as angle 1 and angle 2, but you need to make sure to label those on the picture. So we have our midpoint, we have our vertical angles, and we also have the other angles. So when we want to prove these 2 triangles congruent, we will have 2 angles, one side, having it be angle, angle, side.
And this piece, number 3, that's kind of LT5. We'll get into that a little bit more. But for those of you who are following along, you just have to kind of explain how you knew that AC was congruent to CE. But that's it for LT3 and 4. I know it was a long video, but all the notes were filled in for you. So hopefully you were able to just hit play and highlight as you went. Have a great day.